interesting question here, talking about the equilibrium constant K and the one we call the reaction quotient Q. Let's see how to solve problems relating this. The question here says, for the reaction below, this on the board is the reaction we are talking about. The equilibrium constant at 1700 Kelvin was found to be 6.5. If the composition of the reaction mixture are as follows, it is given concentration of SO3 is given as 0.048 molarity, concentration of SO2 is given as well 0.284 molarity, and concentration of oxygen is given 0.093 molarity. Question then says, predict the direction of the reaction. Predict the direction of the reaction. Let's see how to solve this problem. Solution. Anytime equilibrium constant value is given to you, in this question the equilibrium constant is given. They told us that equilibrium constant, which is K, is equal to 6.5. Anytime you are given equilibrium constant and you are given concentration of the species present at the equilibrium point, and you are asked to use the values given to you to predict the direction of equilibrium, all you need to do is simple. Now that you already have the value of equilibrium constant, the next thing you calculate is the value of your Q, which we call the reaction quotient, the Q. When you find your Q, compare the answer, the value of the Q you got, with the equilibrium constant given to you there. Now, if the K, the equilibrium constant given to you, if it is greater, if the value of K is greater than the value of the Q you will find, it means that the equilibrium will shift to the forward reaction, that is to the right. But if the equilibrium constant given to you is less than the value of the Q you found, it means that the equilibrium will shift to the left, which is to the backward reaction. But if your equilibrium constant K is equal to the reaction quotient Q, it means that the reaction is in equilibrium state. So now that we have our K, let us proceed to finding our Q value. As soon as we find the value of Q, we can now predict. Remember this. If K is greater than Q, reaction will move to the forward direction. If K is less than Q, reaction will move to the backward direction. But if K is equal to Q, reaction is at equilibrium point. Now what do we do next? Let us find the value of Q before we can conclude. Alright, your Q value is just the same pattern, the same way you find equilibrium constant. The usual way we do it, concentration of the products divided by concentration of the reactants. Now that will give us our Q is equal to concentration of the products. I have two products here, so I'm going to have two concentration brackets divided by concentration of the reactants. I have only one reactant, so I have only one concentration bracket. So let's put in the substance. This is SO2 on the product side, raised to the power of each number of mole, 2. Okay, let me remove this. I'll write it here. My K is given as 6.5. Now the second product is oxygen gas, raised to the power of each mole, 1. Remember, before you start doing this, your equation must be balanced. I have said that equation is balanced, that's why I'm solving. Now, the reactant is SO3. I'll put it here, SO3, raised to power each number of mole, 2. Remember, the formula is product over reactant. Each one raised to the power of each number of mole in the balanced equation. Okay, the next thing I will do is to substitute the value of each one. Anywhere I see SO3, I'll replace it with 0.048 given in the question. Anywhere I see SO2, I'll replace with its value. Anywhere I see oxygen, I'll replace. If you do this, you discover that your Q will be equal to SO2 is given to us as 0.284, now raised to the power of 2 from the equation, times oxygen is given as 0.093 from the equation. I will raise it to the power of 1. And SO3, which is the reactant, is given, the concentration is 0.048. I will raise it to the power of 2, according to the formula. If you do this, you discover that the value of your Q will give you from your calculator. If you punch, you are going to have it as 3.3. That is the value. That is, if you punch this with your calculator, you are going to have 3.3 as your answer. Now let us compare the two answers. Our K value is 6.5. Our Q value, which we just got, is 3.3. So from our observation, you can now see that the relationship between K and Q is that our K is greater than Q, because 6.5 is higher than 3.3. Now our answer will be equilibrium will shift to the right. And that is the answer to the question. How did I know that equilibrium will shift to the right? Because the value of my K is greater than the value of Q. Thank you for watching. Keep liking our page, share our link with your friends, subscribe to our page, and drop your comments. Thank you.